examples using conservation of energy, the concepts of potential energy, kinetic energy, and work. The first example, we're going to resolve a kinematics question using conservation of energy. In this case, a ball is launched off of a 20-meter cliff at an angle of 45 degrees and an overall speed of 10 meters per second. We're going to use conservation of energy to find the maximum height of the ball. So first we'll gather information using our goal system. We know that the initial velocity in this 45-degree angle is 10 meters per second, which gives us actually our initial speed. And we know the height of the cliff is 20 meters. We also have an additional piece of information now that we didn't have originally, which is that the total energy can be written as 1/2 mv squared plus mgy for this ball. So the energy over this system, which does include the Earth so that we can include the potential energy, is given by this E total. Now we're going to organize our approach. First of all, we're going to have an initial energy, which is 1/2 mv naught squared plus mgy naught, where these v naught and the y naught were given in the problem. And then we're going to have energy at the maximum height. And at that height, we know that the speed is actually 0, so the kinetic energy term goes away, and all of the energy is in the potential energy due to the height of the ball. We're going to call the height of the ball at the maximum height y max. And we're going to be using energy conservation, so we know that E naught equals E max is equal to this E total, because energy is conserved in this system. So our goal here is to solve for y max using this equation, where we've now set the energy initial equal to the energy at the maximum. And again, there's no kinetic energy at the maximum point because the velocity is 0 at that point. Rewriting the equation, we can now cross out the mass from every part and then divide by g, and that gives us y max on the right hand side and 1/2 v naught squared over g plus y naught equals y max. Can plug in, we know that y naught is 20 meters, and then for the other part we know that the initial speed is 10 meters per second and the acceleration due to gravity is 9.8 meters per second squared. And from this we can get that the maximum height is actually 25 meters. Most important thing for you to always do when you're doing these problems is check your units. So we can check this. Of course, this very first part of the equation, we have v naught squared, which is meters per second quantity squared, and that's divided by the acceleration due to gravity, which is meters per second squared. The second squared on the bottom of each of the terms can cancel. That leaves us with meters squared per meter, and that one of those meters from the bottom can cancel with one of the meters from the top, which leaves us with meters. So that is the correct units for the displacement y. Of course, y naught has the units of meters already, and y max also then has the units of meters as we would expect.